All right, this is throttle stuff. There's more to it than the blade. You know what the throttle blade is and all that. Have you ever seen, I was talking to Justin, came to me, and Justin, what were your symptoms on your, and yours is electronic throttle control, your F-150.
Yeah.
And what were your symptoms? Talk loud so the camera can hear you.
I say like when you roll up to a stop or a red light, you know what I mean, but you're not quite all the way stopped and it turns green, you go. Like throttle plate like stuck and then it jerk.
Yeah, it would sit there. You're mashing the gas. You're not getting anything. And then all of a sudden, it jerks a crick in your neck and takes off.
Yeah.
And what did you find when you did an internet search on that?
People replacing PCM,
Replacing engine controllers, reflashing.
replacing a bunch of stuff.
And what did you do to fix yours?
Just clean the throttle body.
You cleaned the throttle body. That's all you had to do to fix it. There was no reflashing necessary. Now we used to see this on cabled throttle bodies. And now why does it stick?
Because carbon.
Where does the carbon come from? Huh?
The intake, when it steams back up.
Yeah, when the VCV system is actually pulling crankcase vapor out of the crankcase all the time. You shut off the car, and from the closure hose, and it steams up, and you got all this oil vapor and everything inside the intake, and it condenses and turns into that black sludgy crud, and then it sticks your throttle plate sticks. And sometimes if it's a cable-driven throttle, you may step on it and it feels like you're standing on a brick for a second, and then it goes pop, and it does that. My wife's throttle body was doing what yours was doing on her 2006 Explorer. It was sticking like that. And so, anyway, why do we need the blade to begin with? I love the way whenever I build my PowerPoints on the computer I have at home, and then I bring them up here and I run them on that machine there, even though it's got the same version of the PowerPoint on it, it covers up some of my words, so I have to remember what words I have. The throttle blade mechanically regulates the air volume to the atmosphere, pushing it so. In the old days, there was a venturi above the throttle plate. The venturi is right here. And John, you've been reading about this in that book that I got for you and Dr. Rodell.
Yep.
So right here, you've got a jet, right? And as you open the throttle plate and the air is going through here, you're basically going to create low. Have you ever seen me take a hose, like and you put a hose in a bucket and you stick that hose out here and you blow air past it and it starts misting that water out? That's the venturi effect. That's what that is. And that's what this does. Stop whistling. All right, so right here you've got this jet, and it's drawing this fuel up here, and it's turning it, it's atomizing it, and it's putting it down here. Now, on those old days, whenever this was cold, you'd have your choke plate that would close so that you would have more fuel there. But you would also have a lot of this fuel that is turning into mist that was trying to condense against here, and it would cause problems. So basically, instead of having that happen, and they wanted it to stay mist as long as it would stay mist, you can put a screen under there if you want to and all that. They basically wanted to heat this up. Basically, Ford Escorts had a grid under them, some of them that would get really hot. You got your early fuel evaporation on your GM. On some of the old 390s, I don't know if that one that you've ever seen that before on some of the trucks like you got, it would basically have heater hoses going through a thing that was underneath the carburetor that was supposed to get it really hot really fast. But anyway, there's your throttle plate looking down through there. Now, the choke plate richens the mixture by cutting off some of the air. A rich mixture is required for cold engine starts and to keep a cold engine running. Do we need this on a fuel injected engine?
No.
What? Not a choke, but do we need a richer mixture when it's cold?
Yeah.
We do. I mean, the engine that's underneath all that fuel injection still needs the same thing it always needed, So when the engine warms up, the plate's open and no longer influences the air-fuel mixture. Typically, this choke plate is going to be completely open within about 90 seconds on one that's got a heated choke, right? When the throttle valve is connected to the linkage accelerator pedal, controls the amount of air and fuel. Now there is in here that's not pictured an accelerator pump. And the accelerator pump is basically a little diaphragm, or it'll have a little cup that looks sort of like a, wheel cylinder or something. When you mash it, it's basically going to squirt fuel out on those venturi that is going to overcome the gravity that's where the fuel's having to come up out of those venturis. It's not going to happen instantaneously, so you got to have an accelerator pump. And when there's no air flowing through there except what you're spinning, the accelerator pump's gonna wet the manifold and keep it, and so that it can start up. All right, so the additional fuel delivered when the throttle's open is gonna unite with the oxygen it burns. Now, what is it that expands in there? What is it that expands? Yeah, hey, you dissed me, man, how come you didn't show me?
Well, I had a few things go on this morning, all that, and I ended up having to ride with my buddy. But I've been meaning to get over here. I've been busting ass ever since I had a test at 8 o'clock this morning.
All right.
But I got some stuff I got to pay and all this jibber jabber. But I'm probably gonna be Monday.
All right, well.
But I just
I'll be looking for you Monday morning, don't be late.
All right, no problem.
Yeah, to make him account for that. All right, so anyway, what is it that expands and pushes the piston down?
Combustion gases.
Well, what is it? I mean, actually, think about this. What's in the air that's going in there that's mixing with the gas? And what else? Nitrogen, hydrocarbons, nitrogen. Most of it is nitrogen, isn't it? 78%. So what happens when the oxygen, there's a little bit of oxygen in this hydrocarbon, the nitrogen expands. Yeah, the nitrogen expands, and then expanding nitrogen is what pushes the piston down. The nitrogen's inert, but it's actually, this is you'll call it the working fluid, right? Whenever it's actually what's doing the work. Now the explosion happens because of the other, but the nitrogen's what's expanding. You don't usually hear that, right? Because it's most of what's in there is nitrogen.
The explosion is probably the initial kick, but then afterwards push the rest.
The nitrogen gets really hot, and when the nitrogen gets really hot, it's pushing it on down. But the oxygen is what accelerates the combustion and unites with the carbon. Anyway, the throttle blade directly controls the power of the output of the engine. So where is the front of the engine in this illustration right here? Which is the front? Is the front this way or that way? And how do you know?
This way,
Which way?
your way,
Toward my way? Okay, how do you know?
it's turning clockwise.
Yep. That guy's just really smart, isn't he? Because of the direction it's turning, unless it was a Corvair, he's right. Okay, so it's turning the right way there. As points, ignition morphed into electronic ignition, and fuel delivery morphed into Venturi delivery, electronic and fuel injection. The age-old system of accelerator, pedal linkage, and throttle blade has changed into electronic throttle control. Okay, and there's some pictures up there like that. So with fuel injection or an engine controller, I tell you something else a lot of times you don't recognize too. Have you ever seen, like on this the Bronco out there, the throttle cable is hooked to a system of levers? It doesn't just hook directly to the throttle plate. It's actually got levers and stuff and little throttle ball joint looking things. And so that whenever you're moving the gas, the butterflies are moving at a particular rate that is geometry causes it to open at the rate they want it to, instead of just having it directly hooked to it. You know, the engineers came up with that on some of those to make the throttle plate open at an angle that wouldn't, cause stumbling or whatever, I guess. But anyway, make a decision on the fly. Choices of the driver, is basically the engine controller's got to be able to tell what you're doing. But then this one here, this has got a throttle cable, and it goes around that. And okay, somebody tell me what that is. What's that?
Throttle position.
And what's that?
I'm gonna guess it's your auto air control.
That's right. That's a good guess. When the vehicle's first started, the driver doesn't have to do anything. This is no touch starting. Now, on that 69 Ford that we don't usually work on vehicles that old, that 3 on the tree one that we're working on out there, when you get in there to start it up, there's 2 things you got to do before you turn the key.
Check some picture.
Yeah, that's a good thing, but I'm talking about related to getting the engine started.
You have to hit the gas.
You're going to have to hit the gas and you're going to have to pull the choke, because it came with a choke knob, right? All right, the idle air control opens wide, the injector's double pulse to wet the manifold, like the old Accelerator did. The engine still needs what it always needed. Now, every now and then I like to tell this little story about this 97 Altima that went over to shops all over the place around there, and they were all trying to figure out why it started hard. Remember that story? It just started hard, but once it started in the morning, first thing, you could drive it all day, and usually if you started it regularly, you didn't have any trouble. And so somebody had put an engine controller on it, and that didn't fix it, and they took it back off. Anyway, they were trying to charge the lady a bunch of money for, you know, stuff that didn't fix the car. So she just brought it over here, because she was enrolled here, and she figured she'd go over here and give us a shot at it. And I just thought about it for a couple of days, and I was thinking, well, I wonder, it sounds to me like one that you're trying to start without hitting the accelerator pump. I got checking the injectors, instead of double pulsing when you would spin it over, they were basically just firing sequentially like they would if the engine was idling, and that wasn't enough gas to start a cold engine, right? So I went to the engine controller, and I think it was pin 20 that actually receives the signal through the ignition switch when you turn it to start, wasn't getting hot. And so I looked at the schematic and I said, well, pin 20 carries the start signal to the engine controller through the fuse box, and there's a fuse that is over there. Let me see if that fuse is blown. And somebody who was driving the car had pulled that fuse and put it somewhere else. And so when I put that fuse back in there, it went, that's all was wrong with it. Somebody had put a fuse in the wrong place. But it had to do with understanding the fact that the injectors have to double pulse to do what the accelerator pump used to do. See, that's not all that complicated. If the IEC doesn't open though, if it's stuck closed or if it's bad like on one of these, you're going to have a hard starting vehicle unless you put your foot on the gas and just hold it a little bit, let a little bit of air in there. But there are so many people out there nowadays that are accustomed to just spinning it over and starting it up. A lot of the times they don't know. I knew one woman that her vehicle stalled because of some, you know, throttle body issue, and she called me to come see about it, and I came to see about it, and I looked, and she says the oil light came on. And I said, the oil light came on, really? She says, yeah, it stalled and then the oil light came on. I said, well, see if it'll start up. So she started it up. And I said, well, that's all you needed to do. And she said, well, I've never, you know, she's always had nearly new cars, and that one stalled. When she saw the oil light, she thought it was a kiss of death. You know, but if it stalls first and then the oil light comes on, that's not a problem, really. It just means that the oil pressure went away because the engine stalled. At key on, the engine controller gathers data on barometric pressure. It'll get that from the map sensor or the mass airflow typically. Coolant and air temperature, and closed throttle position is basically going to be stored for the entire engine cycle until key off. Now when it's at part throttle, it's going to be holding the idle air control up and a dash pot function, and when you let off it comes down slowly so the engine doesn't stall. If for some reason this is not, you know, if something's wrong, like you've got wire connectors that aren't right, or a throttle position sensor that doesn't reflect that baseline that it got whenever it first started it, you're going to see one that's going to idle too fast.
Well, I'll tell you this, on my truck, you know, it's not just mine, it's about all of them years, they idle up very, very high when you first crank them up. It's cold.
Yeah.
I mean, they idle up higher than the normal vehicle.
Yeah, and some people just don't like that and think it's just the most horrible thing in the world. Now my truck, I don't know, my truck's got a 4.3 or, you know, that smaller motor 4.2, and it doesn't do that, but it's got electronic throttle body on it too, but yours is a different motor, so you don't ever know. Unless you can compare another truck to it that's brand new, and then you can tell if something's out of filter. If any of these inputs don't line up with reality though, as far as barometric pressure, coolant, air temperature, your closed TPS voltage is pretty important as far as throttle body operation. Any of these inputs don't line up with reality, there's going to be problems. Now, here's what the GM and the Chrysler and a lot of the others have got a stepper motor. And what you got is this for the purpose of our discussion, and incidentally, if you go into your Electude and engine performance, and you guys better be doing that stuff, you know, because you're not going to learn as much if you do a crash course marathon in it for 3 days and nights and killing yourself. If I was in the position you guys are in, I'd be knocking out about 15-20 minutes a day on that, and then at the end of the term I'd be done. And I wouldn't have to do all this staying up all day and all that, trying to scramble to get through to get a passing grade. Anyway, this thing right here is going to turn in little segments, little steps, and it's got a nut that's hooked to it. Now imagine a nut that turns, and there's a threaded shaft in there, and that moves out and in. And each time you got one power, and let's say 3 grounds, there's variations of how this works, but it dithers those grounds to it, and it turns that stepper motor in steps. You've actually got an animation of that in your Electude that's really good, showing you how those stepper motors work, so don't neglect that. Your forward idle air control is basically, and you can go into the forward ones, and you can dial up the amperage going to this variable, the variable 4 solenoids that do your transmission pressure work real similar to that. The more current you deliver to it, the more it moves and all. Now, the idle speed will initially be higher at first start than it is with a warm engine. How do they do that on the carburetor? You remember? What do they call the part that does it? It looks like a little saw teeth. Fast idle cam. What they call that? And when the choke is shut, when the choke first closes, there's a little vacuum brake that opens at about 1/8 of an inch and then it comes back. But while it's partially closed, it's going to be idling faster too.
You talking about the choke pull-off?
Now, the choke pull-off is what opens it back up, but there's a little saw-toothed fast idle cam that's got several different steps on it.
Is it kind of just like a lever looking thing?
Sort of, but I can show it to you on this motor out here, but that's a fast idle cam, and that's one of those things. And the idle stop screw rests against it. But it comes back and it's not in play whenever the choke is fully opened. All right, when the throttle starts to open, the PCM monitors the amount and speed of throttle opening. It doesn't just monitor how much it's open, it monitors how fast you opened it. And it needs to know that, so it'll know exactly what to do with the fuel delivery and ignition timing and the other things that it's going to change. But if you slap the pedal to the floor, it's looking at the rate of opening. And all of these things do that. Some of them even have a PID for it on the scan tool, the throttle opening rates, All right, and so it adds some injector pulses while you're giving it the gas. If you're looking at a really concise pattern, you'll see additional injector pulses being inserted between the other normal pulses that are pulsing. See, the crank sensor puts out that reference, and it decides how often the injectors fire. They're going to go click, 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 and then whenever you speed it up, they go click, 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 click. They go faster, but the pulse width changes as well as the cadence that they fire, because they have to fire faster if it's a sequential system or if it's not, as the engine picks up speed. But it's going to add additional pulses, and I discovered that looking at the SBDS system, all these extra pulses when the throttle was opening. And why does it do that? It's acting like the accelerator pump, right? You might think that was only needed on the one because of the venturi in a carburetor, but even a fuel-injected engine needs to add additional fuel whenever you're applying the throttle. Because what are you doing? There's momentum needing to be built, right? So you're going to have power for that. Why do so many throttle plates have a small hole in them the way like this one does? Well, it also kind of helps. There's some air going through there, and it's an easier transition from a little air to more air than it is from, no air to a lot of air, because that'll cause a stumble even under the best of
Probably not as bad as I say like a suction.
Yeah. Well, it basically is there so that, and also if your throttle body starts to clog up, you're getting enough air through there to where you don't have stalling issues and bad and all that. Adaptive learning, though, kicks in. As the throttle body clogs up, adaptive learning kicks in, and you wind up with idle air control numbers that are higher. When you change out the battery on some of them, like on a Dodge, it may forget that hogwash if you didn't plug something in there like just save all that memory. Then when you crank it up after you change the battery on a Dodge, it may crank and go dead, crank, go dead, crank, go dead. And what you need to do when you're changing the battery out on a Dodge is clean that throttle body. And remember, if you're working on an electronic throttle body, don't open it with your finger, because on some vehicles that'll cause you to have another throttle body. And so make sure you have somebody open it with their foot on the pedal, and you just be out here without the engine running and the throttle plate open, because even when the engine's not running, you operate the pedal, it'll move the throttle plate.
Even if it's unplugged.
If anything's unplugged, it's not going to happen, But obviously, if your battery's off, it's not going to happen.
What I'm saying is, you can't even open it with your finger, even if it's unplugged.
Don't open it with your finger ever. I mean, think of what's at stake here. Now, let's say you get by with that 9 times, but the 10th time, maybe you're working on a Nissan and you've been working on Toyotas and other vehicles. You open it on a Nissan, all of a sudden it doesn't work anymore. It's on you. I mean, kind of say, well, what happened? Well, I opened it with my finger. Well, the other 10 times it didn't. It's like Russian roulette. Yeah, click, click. You know what I'm saying? We don't want to go there. So make sure that somebody, it's not a good idea to even do that. Some people may get away with it, get away with it, and not have a problem. I'm not going to go there. ETC was first used on vehicles in 1986. Now this right here is a throttle plate that's above the regular throttle plate. And if somebody got too rambunctious, I saw this on Lincoln's first, somebody got too rambunctious and got to digging out and spinning their wheels too much, the engine controller would shut this throttle plate to throttle it down so that they couldn't drive so dadgum fast. Because there's no use in just burning the tire slam off of it. So because some of those Mark 8s, I mean, if you disable this and punch the accelerator, it would continue to spin until you didn't have any tires left. So those things would have stood in amongst them. All right. On some high-end vehicles like the Mark 8 and the Lexus, that came off a Lexus there. An electronically operated choke was basically there to, keep people from over-throttling. Now, less hardware is needed when you got throttle body, but there's more software. That eliminates the need for hardware needed for idle speed control and cruise control. But you don't need an IAC motor. You don't need a cruise control servo. When I bought my 07 F-150, it didn't have cruise on it. I bolted the buttons on there and plugged them into a place where it already had it. And I went in there with IDS and told it I had cruise. You got to know how to do it. And when I told it I had cruise, now when I set my cruise, the little green light comes on the dash. I didn't have to put anything on it except a couple of buttons, and it was $52 for the buttons. And see, you don't need anything to open the throttle body for you because the engine controller already has all that built in. Power stroke diesels were like that. In the 7.3s, I could put cruise on a power stroke diesel by adding a brake pressure switch and putting buttons on the steering wheel, and all the software and everything else from this. All right, if the PCM can control the throttle plate, it can handle either function as a part of its own algorithms. All right, so you got your throttle by wire here. Now, fly-by-wire systems have been in place on aircraft. They have multiple hydraulic lines and multiple electric lines and multiple computers and multiple everything because they're in a situation where if some of that fails, people are going to die. So basically, they have multiple everything so that they got backups. Like even if something damages, particularly military jets, they're taking all this fire and bullets are ripping their hydraulic lines, and basically if they got three going to the same airline, they're not going to lose hydraulic on all three of those. It's three separate discrete systems. Well, on this one here, redundant sensors provide a higher level of reliability. Driver intent's determined by putting a sensor on the accelerator pedal. The PCM uses that information to determine what to do with the throttle plate. So you got feedback from the throttle position sensor and output to the actuator, input from here. So input, feedback, and output, what you got there. There's another sensor on the throttle body, which I was talking about there, and there's a motor on the throttle body. Now, some of the early 6-liter engines, because they had EGR on them, and it's really difficult on a turbocharged engine to put EGR in there if you don't do it right, they had a throttle plate that would close up to create low pressure so EGR would go in there. You know what I mean? Then they did away with that. They put a scoop on there in 05 and did away with that. That was a different thing. All right, so anyway, let's keep going here. Redundancy for safety dictates there will be more than one sensor on the accelerator pedal, but the sensors, and they send pedal movement position information, aren't the same voltage. All right, for example, this one right here is the diagram of the sensor on a Duramax, on some of your early Duramax engines, and they basically are drive-by-wire too because they use the diesel part of it to give you the change of fuel and all. They don't have a throttle plate, but they've got a redundant sensor. And on the original old 7.3 Power Stroke, you basically had a potentiometer and an idle validation switch. And if either one of those failed, the engine wouldn't do anything except idle, and you'd have to replace the accelerator pedal assembly. Because it came with that. Some of them have only two sensors on the pedal. You notice this goes from 0.75 to 429. That goes from 429 to 298. That goes from 398 to 3.2. I mean, these are just all over the place. You know what I mean? This is the three different potentiometers right here that you're looking at. See that? Yeah, all of them move together, but the voltages are just all over the place. But the engine controller knows what to expect. If this one right here is not showing movement, but these two are, you're going to have basically going to reduce the power. So, and if two of them fails, you won't even be able to do nothing but idle because it needs to know what you're doing with that accelerator pedal. And they made it so that if it fails, it errs on the side of caution and takes away your ability to apply the throttle. Some of them will hold the speed up a little higher so you can, drive a little faster than snail maybe. But the two sensor systems vary in their patterns. This is one waveform that you're going to see. This one here has got a waveform that's a lot lower than the other, and it basically is going to average them out. When you combine it, it calculates an average of the two signals on this two sensor system, and a lot of them have just got two sensors instead of three. One of the things I ran into on that one car was I was doing these sensors, checking it with an oscilloscope, and while the oscilloscope was hooked up that I was using, the PCM wouldn't react. This is another one here. This is from a 2005 model. You can kind of get the idea what you're looking at. Accelerator pedal position sensor. here, and then your TPS. See, the TPS mirrors on that particular one. All right, the TPS signal on that throttle body is also a redundant signal. The two sensors have to agree the throttle plate's moving. Not really a big deal. GM started using electronic throttle control on a lot of their pickups and SUVs in about 2000, but the existing Delphi controller apparently wasn't fast enough, so they put a little box over here on the side that would operate the throttle control, and it interfaced with the PCM. Throttle control actuator model was responsible for receiving accelerator pedal and talking to that, but the engine control module was basically interfacing with it too on that UART serial data line. See, because this controller wasn't fast enough to do what this was able to do, and this thing here had one job. Your cruise control was actually talking to that throttle actuator module too. Well, Ford faced the same problem, but waited a little while until they had this Black Oak processor. You know the one that's got the 3 big connectors going to it? That's your Black Oak processor.
That's the one I got.
Exactly. And it's because you got electronic throttle control. They had one that was fast enough. This is what it looks like on a Ford area PCM. Is basically able to do it because it communicates a lot faster. When a concern is present, the instrument panel will either illuminate a wrench light or a throttle body warning light, and text-capable clusters might spell out a warning that tells you there's something wrong with the throttle. Forced, limited, power, whatever. The throttle sometimes will either open only halfway or not at all. You can't have full throttle if your wrench light's on some of these Fords, And in order to, this is something a lot of people don't know, that engine controller doesn't allow the spring to close that throttle body. It drives it both closed and open, so it can operate it really fast. And this is what it looks like if you scope it. It basically, you notice, this is happening so fast that the magnetic field doesn't have time to decay. So basically, the more it drives it, the stronger the magnetic field gets, but it's pulsing this really, really, really fast. Like 1,000 times a second, something like that. And that's really, you see if I need to turn that back off so I can do this. All right, in normal mode, it's selected at power up and will remain active till a problem is detected. Once a problem is detected, the appropriate action will then be taken. Limit performance is activated when the driver intent can't accurately be determined or when the output of the engine power is impaired. Maximum power is lowered, throttle blade control is slowed down, and the warning lamp's activated. And then forced idle mode is activated when no driver intent is available. It doesn't even know what you want to do, so it's not going to do anything with the throttle. See, one of the scary things about electronic throttle control to the engineers was, what if this thing runs away? And they didn't want that happening. This book can be called the accelerator pedal position sensor not being connected to the engine control module. A short circuit, like a wire that's rubbing against ground that comes from that system, can also cause that to happen. I've seen that before. Power management mode is activated when the ECT system can't reliably control, that's supposed to say ETC, engine power using the throttle. The throttle is disabled so it can return to the default position, and it's controlled by using fuel and spark only, and that's usually caused by an inability to position the throttle blade. If it can't move the throttle blade, it does what it can by using other things. And then right here, when the ETC system is unable to reliably process control algorithms or can't control engine power, it's generally caused by an internal processing problem in the ECM. If it knows enough to know if it's going to just go totally ballistic, and so it shuts down to save the driver, basically with that. All right. Well, I got to put batteries in this thing. Okay, we got just a couple of minutes here. We're just going to go through about 3 or 4 of our questions. The washer around the base of some spark plugs is there for the primary purpose of what?
Conducting heat out of the spark plug.
Conducting heat out of the spark plug. That's a good answer. Put B on that one.
I need it.
Even if the toe adjustment is correct, the vehicle will generally pull toward the side with the most blank camber and the most blank caster.
Negative camber, positive caster.
Positive camber and negative caster. Positive camber and negative caster are supposed to be A.
All right, hold on just a second.
Technician A says positive temperature coefficient thermistors increase their resistance as the temperature increases. Is he right?
All right, hold on. Positive temperature.
Positive means that the hotter it gets, the higher the resistance is. That's what you'd expect. Technician B says the temperature decreases. Negative coefficient thermistors reduce their resistance. Now he's wrong.
A's right.
Yeah, as the temperature decreases, as it gets colder, the negative ones get more resistant, right? Banjo bolt fittings such as the fluid connection of the brake caliper